Right. We have seen what is the hash map and different methods available in the map. Right. Today we'll see different iterations. Right. Map will follow. Right. Like this map interface. What are the implemented classes? Hash map, linked hash map, tree. Right. TreeMap will again implements navigable map will extend sorted map will extend map. Internally hierarchy will be like this, but basically map implemented classes are hash map, linked hash map, tree. Right. And we have a hash table. Right. That is a right legacy class. Right. We'll see that also. Okay. Now we'll start with what are the different iterations. Okay. We'll create a separate. Okay, let me create one more class. Okay, class. HashMap iterations. Okay, we'll create a main method. But just we'll copy this. Right, map we can iterate. Right, first of all, what is the method to get the data from the map? By using the get method. Right. Right, we will first a simple one. We will try with the entry set. Right, entry set. What is the entry set will return? It will return the set. Entry set. There is a method called entry set. Entry set will return set. Right. Entry set will return what type of set it is? Entry of entry. It is a entry. Right. It will return a entry. We can create map dot entry or I think no entry map dot entry. It will return a right entry set of entries. That means each entry is one key and value pair. Right. It is simply a set. How to iterate set? Set of string means we will keep it as a string. Set of a double means we will keep it as a double. Set of string means we will keep it as a string. Similarly, set of entries. Right. That is map dot entries. Set of map dot entries. We have to keep this is the what it is written. Set of map dot entries. Right. What is the type of map? String comma double. Right. That map dot entry string comma double. This is one track. That means we are iterating one by one entry. Right. Entry set will return the set of entries. We are keeping that. This is like a simple string double array. Right. Map dot entry. From the entry, we have a method called get key get value. Get key get value. Get key and get value. Right. If we run it, right, it will print the key and value. Right. It will print just whatever we have printed key and value in this format. Right. Entry set will return set of entries. We can iterate one by one entry, and then we have in the entry get key get value. Get key get value. We will see one more thing. Key set. Right. Using key set, there is a one more method called student marks dot key set. Right. Key set. What it will return key set? Key set also return set. Key set return set of keys. Key set will return. Don't confuse about it. Entry set will return set of entries. Key set will return keys. key set will return keys. And in the map, I think we have a suppose key set. We have it will return the keys values. Right, key set will return the set of keys. Set of keys. Values will return collection of values. That means all the values. Key set will return all the keys. Values method will return all the values in the form of collection. In the form of collection. Right. Key set will return all the keys in the form of set. Values method will return all the values in the form of collection. Right. Here we are getting the key set. All the keys. Once we have a keys, what we can do? We can iterate one by one key. We can iterate one by one key. Right. We can just print the key value. How to get value? Student marks dot get off pass the key. We have a key. Right. Pass the key. If we pass the key, we will get the value. Right. First we get the key set. Once we get the key set, iterate one by one key, get the key. If we have a key from the map object, we have a get method. We can pass the key. It will return the value. Right. It will print same thing. Right. This is one more way. And we can use iterator. Right. Either we can use iterator on this. Right. It is a set. It is returning set means we will have a iterator. Right. We'll see. Right. Student marks dot entry set dot iterator. Okay. Entry set dot iterator. What it will return? It will return a iterator of entries. Right. Iterator will return the iterator object of type entries. If we have a iterator, what we can do? While iterator dot has next, then we can get the, if it has a next element, it will return. We can get the element by using iterator dot next. Right. It will return one by one entry. We can get a one by one entry and call the get key get value. Right. Entry set will return set of entries. On the set, what we can do? We can call the iterator. Right. We can get the interviews. They will ask sometimes like this. I want by using entry set and iterator combination. Can you write the code to print the map? Right. First, we can get the entry set. On the set, we can call the iterator. It will return the iterator of entries. What type? What is the type entry? We can iterate one by one entry and print the key and value. Right. Similarly, on the key set also we can do it. Right. On the key set, if we call the iterator, right, we will get the iterator of string. Then while iterator dot as next, get the by using next method, we can get the key. One by one key and get the value. Student marks dot get the value. Right. Either we can use for each method or iterator. Right. These are the multiple ways we can do it. Right. We can also use a simple way, lambda expression. Lambda expression. By using for each. Here we have a two value, key and value. Key, comma, value. We can give any name, either A, B, right? Any name. In the parenthesis, give the key and value, lambda expression, and then if it is a single line, we no need to give these are all. Within a single line, we no need to give all these things also. That is just directly we can print it. Anything missed? One more bracket, right? For each inside key and value, lambda expression, then system.out.println key and value. Right. In the list concept, we will have only one. Right. Only one and system.out. Here we will have a key and value. Key and value, lambda expression, and then system.out.println. Right. On the iterator also. Right. On the iterator also we can use for each remaining. Here also we can use iterator has a for each remaining method. Student marks dot key set iterator for each remaining key. We will get what is the key entry. Right. We will get a key. So key. This is the key set, right? It will return the keys. We will iterate one by one key into the value. Right. On this also we can use entry set also. Right. These are all the different ways. Which one is comfortable? Just learn. Don't try to learn all the things. Right. Don't try to learn all those things. Right. This one is just we can Google it and copy paste it. But for interview purpose, whatever easy, but just learn this one. This one is important. Right. Iterator entry set combination. Entry set iterator combination is important. One is just learn this one, lambda expression. Right. This one lambda expression. Right. One or two ways you can learn it. Important one is this lambda expression. One is entry set and iterator combination. We can remember these two things. Right. Remaining all are not required. Right. If we are, if we have, right, if you are willing to learn, we can learn and remember if we have, right. These are all right different things. Okay. These are the different ways we can print the map. Okay. Fine. Right. Those are the about the HashMap. Right. We'll see now LinkedHashMap. Right. Right. Functionality wise, methods wise, there is no difference. Right. If we create a linked hash map, linked hash map, right? Linked, just change it. That's it. Linked hash map and import it. Right. There will be no change. All the methods, whatever we have learned, put method, put if absent, right? Put all method, get our default, remove method, empty size, all are contains, all are same. Iterations also same. There is no difference on it. But what is the difference? Right, internal structure of it. Right, 1 second. Okay. Okay. I have noted down this right, default capacity, load factor, and these things. Right, array list default capacity internal data structure is a dynamic array. Right, it is implemented inside. What is the data structure? Dynamic array, default capacity 10. There is no default load factor. It is not thread safe. That means simultaneously can access multiple threads can access at a time array list. There is because it is not thread safe. We can access multiple threads at a time. How the right default size is 11. Right, sorry, default size is 10. If you try to insert 11th one, if you try to insert 11th element, right? If you try to insert 11th element, the default capacity is 10. If you try to insert 11th one, what is the how much size it will increase? Initial capacity 10 plus 50% of the 50% of initial capacity. 50% of initial capacity means 5. Right. In initial capacity is 10. What is 50%? Now new size will become 15. New size will become 15. Right. Similarly, once you are trying to insert 16th element, again it will insert 15 plus 15, 50%. What is 50%? Maybe 7. Right. It will become 22. Right. Like that it will work. Grows 50% when it is full. Right. Linked list internal data structure is double linked list. It don't have any default and load factor. It will increase by nodes. Right. Linked list have a nodes. If we add one element, it will create one node. If we add 5 elements, it will create 5 nodes. Right, simple. It is also a not a thread. Vector and array list both are same. Right. What is the difference between vector and stack? Vector is a thread shape. It is a legacy class, right? Vector is a legacy class. It will follow thread shape. That means only one thread at a time can be accessed. If multiple threads are trying to access, it will allow one by one only. Right. It is a thread shape. Stack is also a right. Stack is the child class of vector. Stack is child class of vector. So it is also a same default capacity 10. There is no load factor. Right. It is also a thread safe. It is also a thread safe. It will follow LIFO order. Last in first out. Stack means what? Will keep one by one. Last in first out. Whatever will keep last, it will come first. Right. Stack will follow LIFO. Hash set. Internally, it will use the hash map data structure. Default capacity 60. It will have load factor 0.75. 0.75. That means what? Whenever we'll create a hash set, it will create a default size is 16. When you try to insert 17th position, right? When you try to insert element at 17th position, how much it will increase? New size will become 16 into 0.75. Right? Whatever it may be, new size it will get. Right? New size will become 16 into 0.75. Right? Like this, it will increase load factor. Right? Load factor will applicable only for the hashing. Right? Internally, it will use the hashing mechanism. Right? To store the element, hash set, linked hash set, hash map, linked hash map, right? Hash tab. These are all will use internally hashing technique to store the elements. Only hashing, right? Hash related collections will have a load factor. Remaining will don't. Right? It is also a not thread safe. Right? A tree set will use a red block tree. Right? Tree don't have any default capacity load factor. Whenever we'll increase the elements, right? Storing the elements, it will automatically increase the size one by one. Linked asset will use internally HashMap plus linked list. HashMap plus linked list. It will have a default 16 size is default size and the load factor 0.75%. It is also a not a thread set. Right now coming to HashMap. HashMap will use right. What is the HashMap internal data structure? We can see we can click on it. Right, we can click on it and we can see hash table based hash table. Right, it will use internally hash table based implementation. Right, a hash table. Internally, it will use the hash table and the default capacity 16. Right, if we say whenever we will, if we mouse over, sometimes it will so see default capacity 16, load factor is 0.7. It is also a not a thread set. And a tree map, right, we'll see. Right, we are currently looking at hash map, linked hash map. Right, linked hash map will use, right, it is also a capacity 16, load factor 0.75, internal data structure hash table plus linked list. Hash table plus linked list. Hash table plus linked list. Right. Okay, it is also a not thread safe. Only legacy classes are thread safe. Legacy classes vector, stack, hashtable. These three are legacy classes. These three are thread safe. Remaining all are not thread safe. Right? We can make it as a thread safe. That we can see later. How to make it as a thread safe. Right now coming to actual. Right. What is the difference between HashMap and linked HashMap? Right. Only difference is HashMap will not preserve the order. Right. HashMap, whatever order we have inserted, it will not display in the same order. Let's see, it is displayed in some random order. We have inserted in one order, it is displaying in different order. That means it will not preserve the order. But a linked HashMap will preserve the order. Linked HashMap will preserve the order. Whatever order we have inserted, same order it will display. Right, like linked hash. Right, similarly, here linked HashMap will preserve the order. Now one more thing. Suppose if we try to add null key, is it allowed? It's allowed. Null key, it's allowed. Where it is printing. System dot. Okay, fine. Let's run it again. Right. See null key where it is inserting in the last position. Right, it is inserting see last position. Right, it will allow one null key. HashMap also will allow one null key, multiple null values. Here also it will allow one null key, multiple null values. Only difference between HashMap and linked HashMap. Linked HashMap will preserve the order. HashMap will not preserve the order. And internal data structure. Right, internal data structure. HashMap will follow Hashtable. Linked HashMap will follow Hashtable plus linked list. Right, these are the differences, HashMap and linked HashMap. Now coming to TreeMap. Now coming to TreeMap. Right, TreeMap. Right, just change the TreeMap. Right, TreeMap. Right, there is no difference. All are same only. Right, then if you see TreeMap, it will internally uses red block tree. Will internally uses TreeMap red block tree. It don't have initial capacity load factor. It is not thread safe. Right. Then if you, what is the difference then with the remaining maps? So one thing it will not allow null. One thing it will not allow null. Right. It will not allow null. If we try to add null key, what will happen? Null pointer exception. Right. It will display in a sorting order based on the keys. Right. It will display in the sorting order. Let's see A, B, C, D alphabetical order. Right, we will change this order. Right, here order is there. We will change in. We'll keep this one top. Okay, we'll keep. Now we will object. Right, see alphabetical order A, B, C, D. Right, alphabetical order. TreeMap. What is the advantage of TreeMap? If we want to sort map based on keys in the alphabetical order, then we can store it in a TreeMap. Right, TreeMap will sort the arrays. Internally, it will sort. That's why null keys it will not allow. Null keys it will not allow because internally it will sort the map. Right. While sorting, if it find any null, it will throw null pointer exception. Right. Internal data structure is red block tree. Right. Red block tree. It don't have any default capacity. Based on while adding the elements, it will increase automatically one by one size. Right, that is TreeMap. Right, HashMap will not preserve the order. LinkedHashMap will preserve the order. TreeMap is in sorted order. Right, those things we have to remember. And then if they in interview, sometimes they will ask maybe what is the default right capacity and load factor. Right, we can also remember that. And coming to one more is hash table, legacy map, legacy map, hash table example. Okay, hash table, right, hash table. We'll change it to hash table, right, hash table. Let's see, there is no difference. Here there is no difference. Hash map and hash table both are same only. It will not preserve the order. Right. It will not preserve the order. Right. It will always displace in a some random order. Right. What is the difference then hash map and hash table? This is a legacy class. This is a legacy class. See, default capacity will be 11. Initial capacity will be 11 and the load factor is 0.75. Right. And hash table, this implements internally again hash table only. Internally it will implement a hash table only. Right. This is introduced in 1.0, JDK 1.0. That's why it is called a legacy class. Right. Vector, stack, and then hashtag. These are all right. These are all legacy collections. Only difference between HashMap and hash table is thread safe. Right, because why it is thread safe? All the methods in the hash table are synchronized. Right, all the methods in a hash table are synchronized. That's why hash table is a synchronized thread safe map. Thread safe map. Right, it will allow only one by one thread only at a time. It will not allow to modify multiple threads. It will allow one by one thread only. Right, that is hashtag. Right, if you want to achieve right in real time, right, we will use a concurrent hash map to achieve the threading. Actually, hash table is the old one. Right, we will not use it. Instead of, we will use the see here. Where is that? They have given somewhere. Right, see. Right, highly concurrent implementation is desired. If thread safe is highly concurrent implementation is desired, then it is recommended to use concurrent hash map in place of hash table. Right, they are suggesting if you require a thread safe instead of hash table, then use the concurrent hash map. Concurrent hash map. Right, concurrent hash map. It has an initial capacity 16. Right, what is the data structure it will use? Hash table. It will use hash table internally, but if you want to right thread safety, we instead of hash table, we can use the concurrent hash map. Concurrent hash map to achieve the threading. Right, that means threading concept. If you are using right while running your test cases or your application parallelly, right, we will use a concurrent hash map to achieve threading. Right, that's it. Mm, okay. But default capacity not needed for the node based or tree based structure. Right, like tree, tree set, tree map. Right, these are all default capacity is not there, linked list. Right, node based and tree based structures don't require default capacity. Load factor only applies to hash based structures. Right, that uses a buckets internally to resize the right. Only hashing related collections will use the load factor. Right, remaining automatically it will increase by 50%. Right, these are the some of the map implemented classes: HashMap, LinkedHashMap, TreeMap. Right. Now coming to there are two utility classes we have. Two utility classes we have. Right. There is a arrays and collections. Utility classes. Right. What it contains? It contains a reusable methods. Right. Just will first we'll see. Okay, main method arrays. Right. Arrays. This is the utility class. If suppose if I have okay, if I have one right integer array. Okay, integer array. At integer array. Now by using arrays class name is arrays, we have a all the right sort. If I want to sort, simple. Right, we'll go one by one. We'll see what are important ones. I will tell. Binary search. If we want to search, binary search means what? If I want to search any element is available in the array or not. There is already method. Right. In interviews, they will ask to write a binary search. Right. At least one searching algorithm, one sorting algorithm we should know. Right. Searching, you can learn binary search. Sorting, bubble sort. Right, bubble sort we can. Right, here already in arrays class, in the real time, we don't no need to write again. Right, already, right, we have a classes, already someone written logics. We can use those things. Only interview purpose, we have to learn. Let's see, we are calling directly on the class. That means what type of method it is? Static method. Right, you are calling directly on the class without object. That is a static methods. And also overloaded methods. See, different types of threaded data types. Binary search we can do byte array, char array, int array, float array. It is supporting all. Right, binary search we can provide the array, and then suppose I want to search whether 4 is available or not. 4 is available or not. Right, searches for a specified array of this into specified binary. The array must be sorted. Right, before doing the search, binary search, array must be sorted. Then only binary search will work. Otherwise, will not work. Right. If you want to use the binary search, this must be sorted. So what we can suppose if array is not sorted, we can use the arrays dot sort method to sort it. Before doing the searching, suppose if it is not sorted, then we can use the sorted. Then we can do the binary search. Right. What it will return? Int. Right, index. It will return the index. Okay, fine. But we'll keep it in unsorted array. Okay, unsorted. Then it will sort. Then we can print the what is the index of it. Right. What is the index of 4? Is it not? Right. We have to call after sort. Sort it, then print the array. If you want to print directly ARR, if you print directly ARR, what will happen? It will not print. See, hash code it will print. It will not print the data. If you want to print by using the arrays class, there is a toString method. We can, in the toString, we can pass the array. Then only it will print the array. Directly if you print, it will not print. Right. One, what is the 3? What is the position of it? 1, 2, 3. Right. Position will be 3. That it is printed at searches for the specified array of ints of the specified value of the bank. The array must be sorted prior to making this call. If it is not sorted, the results are undefined. If array contains multiple elements which specify the value, there is no guarantee which one will be found. If you have a duplicate, right, it is saying there is no guarantee which one will be found. Let's suppose if I give right 10. Suppose if I give 10. There is no 10. Now what it is written in? -6. -6 means what? What is the expected position of 10? What is the expected position of the 10? Right, position right after 5. After 5 means right, what is the line? 1, 2, 3, 4, 5, 6. That's right. It is a it should be expecting at a sixth position, but it is not there. So it is written in -6. Right, 10 will be after 5. It is expecting after 5, but not there. Just it is written in position I am expecting here, but not there. -6. That if it is there, it will return the position of it. Right. Similarly, like this binary search, and then compare if you want to compare two arrays. Right. If you want to compare two arrays, suppose you have a one more array. Okay, we'll take it array one. Now, if you compare error one, then what it will return? Int. I think either 0. Right. It will. We'll see. What is the return type? Integer. Something compare. Right. If it returns 0, both are equal. Right. If both are equal, it will return the 0. Right. If both are equal, so it is returning 0. Oh, sorry. We kept both array, right? We have to kept array. Right. It should return actually false. Right. It is returning -1. That means not compared. That means what is the issue here? One is the sorted one, right? One we have sorted one. 1, 2, 3, 4, 5. But the next one is 1, 3, 2, 4, 5. That's why it's not compared. We will sort the second one also. Arrays dot sort array one. Right, array one also will sort. Now compare it. Now if you compare say 0. 0 means both are equal. Both are equal. Right, both are equal. It should be the same order. Then only it will work. Then one more is arrays dot equal. Right, we can also equal. Equal return true or false. It is straightforward. Right, true means both are equal. False means not equal. Simple. Right. It's better to use equal method so that there is no confusion. That if both are equal, it will return true. Right. Now both are sorted. Both are sorted. So it will be same elements. So if both are equal, it will return true, otherwise false. Right, mostly we will use sorting, compare. Sorting and compare we will use. There are a lot of methods are there. Right, arrays dot fill. Fill method, what it will do? Right, suppose if I print now array ARR, we have to print like arrays dot to string. Then only it will print. Right, see, it is filled with 0. Right, all elements are replaced with 0. Right, sometimes we have to create one array with fill the some default value. Right, right, we can do that. Fill means it will fill the and data array data with given value. Right, it is if there is any data, it will replace all the elements. If we want to fill from particular position also, we can print. See, if we want to fill only these 0 to 3 with 10, remaining keep it as it is. Right, we can also do that. Right, we can fill particular elements also. Right, starting to ending position. Right, it is inclusive, it is exclusive. Exclusive means 0 to 2 minus 1. Right, not until 3. At arrays dot sort, parallel sort. If you want a large number of arrays, right? If you have a thousands of elements you want to sort, then we can use parallel sort. That means it will quickly sort the elements. It will quickly sort the elements. Parallel sort means arrays dot binary search compare copy. Right? We can also do the copy. Copy means what? If you want to by using existing array, you want to create a new array. That means I want to increase the size of the array. Right. I can pass. Suppose this is the array. I want to increase array dot length plus 5. Right. I want to increase plus 5 length. Right. It will return the new integer. We have to new int array. Right. We have to copy that. It will not change the existing one. It will create a new one with the existing and increase the size of it. Right. Just if we print it. Right. See. We will copy here array 1. Right, see existing values will be there, but new values it will add 5. Right, default value is 0. So right, copy of these are all very rarely used. We have to check right in arrays class. If you are getting any new thing on the array, you want to do anything, we can verify in the arrays class. Is there already method available or not? Already method available or not? We can verify. Right, and a mismatch. Right, find and returns the index of the first mismatch. Right, if you want to compare whether, right, we can also do like this. If you want to two arrays are equal or not, right, then we can also do like this error 1. Right, if there is any mismatch, it will return the index of first mismatch. If there is no difference, right, it will not what it will return, we'll see. We don't have any right mismatch. There is no mismatch, so 0. If there is any mismatch between these two arrays, then it will return the first mismatch. Let's suppose we'll create 2 and then 3. Okay. Then we will change here 2 and 3. Okay. Then array 2, array 3. Error 2, error 3. Okay, now run it. Let's see what is the where it is mismatched. 0 and 1, first index. First index, we have a mismatch. So it is returned first mismatch. In sort method, these are all right. Right, these are all the usually we will use. Mostly we will use one is the toString to print the data. One is sort, one more is equal. We will use rarely these things. Right. Remaining, if required, we can use it. Right. Fill method, mismatch method. Right. Then compare method, binary search, those things. Right. This is a one more utility class used for arrays. Used for arrays. And one more is for collections also we have a utility class. For collections also we have a utility class. Collections utility. Okay. Collections, we have a class called collections. We have a class called collections. Here also same thing we have. Here also we have a same thing. Let's suppose binary search. You want to do the binary search of the some collection. Create a list of strings. Okay. We can create a list directly like this. Right. In array, we will create a, in arrays class, we have one more thing as list method. Right. In arrays class, we have a as list. We can convert string array to list or integer array. You want to convert integer array to list of integer, right? Like that. If you want to convert array to list, we can use the arrays dot as list. Arrays dot as list, we can convert array to list. Right. 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 Suppose if you want to search for this binary search, right into search. Right. What is the index of? If it is there, it will return the index of banana. What is the index? 0 and 1. Right. What is the index of it? Banana. Where it is found? First position. Banana found in first position. Right. Similarly, sort. Similarly, sort. Before searching binary search, it should be sort. Already it is in sorted. If it is not sorted, we have to sort and then search. Then only it will work. Right. Reverse. Right. If you want to reverse the list. Right. If you want to reverse the list, we have a reverse method to reverse the list. And then what we have? Right. Sometimes we want to shuffle the list. Shuffle the list. Right. We can also shuffle. Every time it will shuffle in different order. Right. Shuffle. Right. Every time it will shuffle. Right. Here B A C it came. Right now came C B A. Right. Sometimes if you want to do right a random number selection, then we go for shuffle, and then we can get the shuffled one value from the list. Right. What else we show? Right. Fill method. Right. We know fill means it will fills the data. Right. Whatever data we have given, it will fill the data. Same thing. Right. It will fill with all with orange. Right. See swap. Here we have a swap method. Suppose that means I want to swap 0 position, 1 position. That means 0 become 1, 1 become 0. Right. We have to print it. So, right. Here we have filled with orange, so we don't know. We will comment this one. Fill method. Let's see. It is 0 is cherry and apple. It is swapped with the apple and cherry. It's swap method. Right, see rotate. If you want to rotate the list, we can also rotate. Let's see, it become cherry here and then apple. Right, that means it is rotating. We can rotate the values also. Right, replace all, we have replace. Right, banana with kiwi. Banana with kiwi. And then what else we have? Right, if you want to reverse order, already we have a reverse method. Right, already we have reverse method. Functions dot. Right, one more important thing. See max value. If you want to get the max value, frequency of element. Right, if you want to get frequency of that means how many times it repeated. Suppose apple is the how many time repeated frequency. Right, we can get the frequency of it. Right, it will return the integer. That frequency. Right, then collections dot max. Right, see max min max value max of the what is the maximum minimum. Right, collections dot copy. If you want to copy one, right, for this list to array. That if you have a array, you want to merge to this one or one list to another list. If you have a two list, otherwise list one and list two, right, we can copy those elements. One more important is now all the color array list, these are all not synchronized, right? So we have a here synchronized list. Synchronized list. If we want to convert list is not a array list is not synchronized, not thread safe, right? It will return a thread safe list. It will return a thread safe list. Right? It is a thread safe list. Right? We can do like that collections dot unmodifiable list. Unmodifiable list means I cannot. It will return the list which is not modifiable. Suppose if you try to modify, right? If you try to modify, that if you try to modify, see what will happen? Unsupported operation. That means we cannot modify, only read only. Right? Read only list. Right. If you want to convert to read only list, we can use unmodifiable list. Unmodifiable list. And also we have a collections dot synchronized set. If we have a set, we can convert to synchronized set. Similarly, map. Synchronized map, hash map, tree map. If we have any map, we can convert to synchronized map. Right. Thread safe maps. Right. Thread safe list, thread safe. Right. We can. Right. If you want to create a empty list, right, we can also create a empty list. It will return the just empty list. Right. We can write empty set. Right. There are a lot of things we can go over empty map. Let's see. Right here, see copies. That means what it will do? It will copy 5 times. What it will return n copies? It will return the new, right, a new list. If we print it and copies, like what is it? Right, there are a lot of methods we can go through it one by one. That we have a somewhere synchronized unmodifiable map list. Are we modifying it? Null pointer. Where is this null pointer? Somewhere collection dot 49. Okay, here we have null. Okay, comment it. Synchronize map also comment it. Let's see. It will copies hello with the 5 times. It is created list. Right, like this, we can go over right all the disjoint. Right, if you want to find the two collections disjoint elements. Right, we can lot of methods are there. Right, you can go over this. Mostly we have covered. Right, if you have anything, just go through it. We will get a lot of methods here. Mostly we will use for right collections that sort. Mostly we will use for only sorting purpose. Right, but there are reverse also sometimes. Right, if you know these methods, then only you can do. Just to go through it, collections. Right, what are the methods available? Right, you can get some idea in the arrays and collection. Arrays class is used for arrays. Collections class is used for collections. These two are utility classes. These are also in the java.util package only. Right, these are also java.util package only. These two are also arrays and collections. Right, yeah, that's it. Any questions? I think mostly we have covered all the things. From Monday onwards, we will start the advanced topics. Right, we'll start the advanced topics. Those are all useful for interview purpose mostly. Right, we'll see those. On a normal core Java, we have completed. Now we will see advanced topics. Right, those are all mostly useful for interview. Mostly we will get those advanced questions only if we are going with the interviews. Right, we'll see those. Yes, Kirti. Yeah, you have anything, Kirti? I think. Red block tree. No, red block tree means what? That is the internal data structure of the right. That is internal data structure. Tree structure. If you know the C++ concepts, you will understand those things. A tree means what? Internally, how it will store like a tree structure. If you add elements in the tree, right? Internally, it will suppose if you try to add, right? Suppose I am first element I have added 20. Right. Second element I am trying to add 10. 10. Then it will compare what it will do. If it is less than 20, it will add in the left side. Right. If it is more than this, right now it will come 10. Now suppose if you try to add 30, it is greater than 20. Right. It will add here. In the tree shape, it will add. Right. If you try to add 5, it is less than 5. It will add like this. Right. If you add 7, right, 15, it will like this, it will go on. It is a tree structure. It will add in a tree structure. Right, if you want to go more details, we have to go through the C++ concept, right, tree concept we can learn. That just it will add in a tree structure elements. Arrays means how it will add like this arrays. Linked list means it will add a links. Right, same way tree means it will add in a tree structure elements are. Because if we add like that, what is the advantage of it? While right adding and searching will be fast. Adding and searching will be fast in the trees. That's why they will store it in a trees, right? To add the element fastly, to retrieve the element very quickly, right? We'll go with the tree structure, right? That is about that. Right, fine. From Monday onwards, right, we'll start those things, advanced topics, right? Okay, yeah. Thanks for joining. I think thanks for commenting all my videos. Thanks for your support. Thank you very much. Yeah, yeah. Thank you. Bye.